Good evening, everyone. So we will start up with the list. Okay. So yesterday we saw like what are lists, a kind of a data type, right? So I said yesterday that you can consider the list as arrays in the C, but you can list this thing as like to enter up the heterogeneous data types, right? Understood? So what I said yesterday that lists are a collection of heterogeneous data type elements, right? What you can put inside the square brackets and you can sum up them. Okay. So the format of writing a list should be, let's say we take some subjects over there and we put a square bracket. Then quickly write up all the subject names, right? So let's say this is mathematics, this is chemistry, this is physics, right? Okay. So you can add, you can just write these things first, okay? So these are the subjects, the physics, chemistry, and maths, PC, right? So if we just check on the type of this, so you'll find that this is a list, right? So a list is a kind of heterogeneous, a list can contain a heterogeneous type of elements, okay? So how to say that? This is because if I say that this is a list, that let it be L1. Now heterogeneous data type means that it can contains a lot of data type elements, right? Every data type elements over there. So let's say this is a string, okay? Let's say this is an integer, this is a float, this is a boolean, okay? It can also hold some tuple values, right? So like this you can write many elements, many data type elements, different type of data in the list, okay? Cool. So we'll see what are the list methods we are having on, okay? Fine. So you can see like in the subjects, if I have written mathematics, chemistry and physics over there, okay, these are nothing but the strings, okay, the same data types you can say as the homogeneous data types are there, right? That is correct, okay. Now if I say, if I do the indexings, if I say that I want the subjects of 0, right? So that would be the first element, that is mathematics, okay. Similarly, we can go on for the ranging things. So that will be the numbers from, or you can say the individual characters from 0 to 1, right? 5. So similarly, you can take out the indexes from these things, okay. Now, there are a lot of methods in the list, okay. There are a lot of methods like you can add up the things, you can remove up things, you can just do replacings over there, okay. So there are a lot of methods, we'll go with some of them, okay. So let's say you want to add something inside the list. So there you have a method called as append, and one more method is there that is called as extend, right? If you want to add up more than one element, then you use extend over there, right? So let's say we want to add some more subjects here. So what we'll do, we'll write the list name, then dot the append, put the parenthesis, and inside this, write whatever you want to append or whatever you want to add on. So let's say we want to add this computer science, okay, right? So just run this and see the subjects. So you will find computer science. Now what happens? Whenever you try to write anything with this method of append, what happens is the every element what you will be writing inside this append will be added up in the last of the list. Okay, that will be in the last section, right? Always in the last one. Okay. Now if you want to add something, right? If you want to add something in very particular index position, then you have to use insert, right? So that is like if I write subjects dot insert, you give parenthesis, and then you will have to write on in which particular index value you want. right? So let's say if we want something in the first position, so that will be obviously 0, right? And then you write whatever you want to like add on there, right? So give a comma and write, let's say this is the, or let's say this is the priority subject. Anyone you can write down. Okay. So just run this and you just see your subjects. So you'll find, okay, so you'll find this priority subject at the first, that will be your first element. Okay. So that is like a lot of methods are there in the list, right? We are not going to discuss everything. Okay, there is a lot of methods. You can go on reading over the, if you browse the nets, you will find it. Okay. Now, there is like, if we can add up the things, we can also remove up the things. Okay. So if you just want to remove something, you'll have a method that is remove. So you use remove and write the element you want to remove. Let's say we want to remove this chemistry. Run this, and if you see your subjects, you'll find no chemistry out there, right? So similarly, there is one more method, that is pop, right? So whenever you use pop, it will automatically remove the last element from your list. Okay, the last element is the computer science, right? So if I write subjects dot pop, that's all. So it says that computer science has been removed. Okay, so there are a lot of methods. So you can remove things from there, right? Okay, understood? Fine. So like list, there is now also if you want to copy a list. Okay, one more thing. If you want to copy a list, so let's say I just want to copy a list. S equals to subjects dot, make it as a copy. Fine. So this is like you can copy a list. If you see your S, it will be exactly like what is the subjects, right? Even you can delete a list just by using del, and you can use this to delete a list. Okay, fine. Similarly, there is data type called as tuples. Okay, so tuple is a sequence of immutable Python objects. Okay, these are sequence just like list what you have. Like it is also having a heterogeneous type of elements, heterogeneous type of data elements over there, data types, right? But the only difference is like you can do editings in this list, right? You can replace anything, you can add on anything, you can remove anything from there, right? But in tuple, what happened? You can't do these things over there, right? So like you cannot change like the list what you do there. Okay. So tuple uses parentheses, whereas list uses square brackets. Okay. The major differences are there. Okay. And the one more difference is that lists are mutable and tuples are not mutable. Okay. Fine. So let's say again we are taking the subjects. Let it be sub. And now this time we are taking a tuple. Okay. So what I say, tuple uses parentheses. Okay. So let it be parentheses. Now again, let's take the subjects: physics, chemistry, mathematics. Okay. So just go quickly and see the type of sub you are having. So that is tuple. Alright. Fine. Cool. Now, let's say we want to find sub of 0 to 2. That is fine. Okay. Indexing is same for the list and same for the tuples. Right. Cool. So the simple answer, if we just say that if we want to find this sub of 0 and if we want to replace it with, let's say, replaced. Okay. If we just want to write these things like this, run this, and you'll get an error out there that is tuple does not support item assignment. Okay, so you can't add on the things over there. That is what I'm saying, that tuple cannot be changed, right? Once you define these things, it cannot be changed on. Okay, fine. So what you can do if you want to like write up a things, if you want to replace up a things in a tuple, so what you have to do exactly? So let's say like in the place of chemistry, okay, like in the place of chemistry, you want to write computer science, right? You want to add on, or you want to just replace it by CS. Okay. So what you'll do is, you'll have a method. What you can do, you will write this sub, and you will make it a list. Okay. So once you have made it a list, you have all the options to edit on, right? So let's say this is now sub, and that is now a list. So sub of 1 would be CS, right? And then again after editing, you write this sub as the tuple of this sub. Fine. Let's run this. So done. That is okay. Now if you see the type of sub, what is it? That is tuple, right? So if we just print on the things, we'll see CS over there. Okay. So that is how we deal with the things, right? That is how we deal up with the tuples. Okay. So you can't add on the things over there. You can't just you can say you just can't replace other things over there, right? So like see guys, you can do one more thing. If you just want to add up one tuple with any of the values, let's say this is your tuple with some values 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is your tuple X, let's say. And you want to add on some different numbers over there, right? Some much numbers over there. So what you will do is you can add on with X plus, make a tuple 12, 12, something like this. Okay. So you can get a tuple with some added values over there, right? That is like append values you can say on. Okay, like an extend value or an append value you can say on for the list as compared to. Okay, so this is like for the tuples, fine. Okay, moving ahead. So you can just practice these things on like how is tuple different and what else you can do in the tuple. You can count on for the things. You can search for the index values over there. Okay, cool. So next our data type is the sets, right? So set is an unordered collection of items where every element is unique. Now when I say that every element is unique, I mean to say that no duplications or no repetitions of any element is allowed in the sets. That is, if you see this tuple, you see this 12 has been repeated for 2 times. Even in the list also you can repeat the number of things, right? If you say this y and this is like 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. So if you write these things like this, right? So y is a list, right? But still we are making some repetitions. We are making some duplications of the numbers, right? That is 4, 4, and 6 has been repeated for 2 times. Similarly, in the tuples also we can see the repetitions. But what in sets, as I say, that in sets every element is unique, and these are a collection of unordered data, right? That is an unordered data. Now, unordered data means that if I write something like this, right, and if I just print it y, I'll see the same order, like whatever I have written over there, right? But this will not continue in the sets, right? This will not be same in the case of the sets. There it will be something different. Okay. So set is created by placing all the items inside curly braces. Okay. Inside this curly braces, you will be finding the elements that will be a set. Okay. And these are separated by a comma like we do in the list and the tuples. Okay. So let's say this is my set name. Just take it 1, 2, 3, 4, 5. Okay. So as I said, in sets every element has to be unique. Okay. So just say that if you see your set name, so that is 1, 2, 3, 4, 5. Right. Now if I write this set 2, and if I say 1, 1, 2, 3, 4, 5. Okay. 1, 1, 2, 3, 4, 5. Now I'll again run on my set 2 and I'll see what comes as the output. So still you can see the outcomes to be 1, 2, 3, 4, 5. Why? Because this 1 has been printed for 2 times, right? But still it will take only one particular value because duplications are not allowed here, right? 1 is repeated for the twice, but it will only print for once. Okay? Alright. Now let's look some of the most common methods and important methods of the set. Okay. So first we'll look out to the method called as union. Now union we all have read, right, in the class 11th and like. So union, like if we consider 2 offsets, let's say this is set A and this is set B. Okay, there are 2 sets. So if we want to find the union of the sets A and B, so union of A and B is a set of elements from both the sets, right? So union is performed using an operator that is this. Okay, you can write this operator to find the unions. Okay, so let's say A is equals to 1, 2, 3 and 4 and equals to 3, 4, 5 and 6, right? So 1, 2, 3, 4, 3, 4, 5, 6 are there. Okay. Now I'm going to make a union of these sets, right? I want to find a union of these sets. So if I say A dot union of B, run this, and I'll see 1, 2, 3, 4, 5, 6 over there, right? That is the combined values, or you can say all the elements in the set 1 or in the set A as well as in the set 2 or in the set B, right? Similarly, you can also write it as print A, B. Okay. Next. So next up, let's see the intersection. So intersections of any two sets, right, that is like set A and set B, intersection of two sets are the elements that are common in both of the sets, right? The common elements in both of the sets, right? So intersection is performed using the AND operator, right? So let's say again we are having A and B, we are just performing that A intersection of B. A intersection of B. So you will find this to be only 3 and 4. Right? You will find this only to be 3 and 4. And why is this so? Because if you see your set A and if you see your set B, what you have this 3 and 4 as the common elements over there. Right? These are the common elements of the set. Okay? So similarly, you'll be getting the intersection to be 3 and 4. And what I said, you can also use set A and set B. This AND operator is very useful in the data science field. Okay, so we'll be using this in the pandas. Okay, so let's run this, and you'll see 3 or 4 over there, right? Similarly, there is one more thing, that is difference. Okay, now difference of any two sets, that is set A and set B, if we consider on. So difference is nothing but set A minus set B, right? That is A minus B, okay? And that is a set of elements that are only in A but not in B. Okay. If you see, if I repeat it again, so let's say you are taking set A and set B and you want to find the difference between the set A and the set B, right? So it will be the set of elements that are only present in the set A but not in the set B, right? So similarly, if you take for the set B minus set A, right? So that will be the elements present in the B but not in the A. Okay. So let's say we are having A and B. We just want to print this. That is A minus B. So the elements present in the set A but not in the set B is 1 and 2 because 3 and 4 are the present. 3 and 4 are present in set B, right? Similarly, if you write for B minus A, you'll get 5 and 6, right? That is much similar, right? Also write difference of B. So you'll still get the same things, right? B dot. Many a times you'll see these things over the browser if you search for this. So difference here. Still get the things. Fine. So these are some of the common things we use in sets, right? So there should not be any common elements, any duplications over there, right? Okay, now we come up to the data type of the dictionary. Okay, so I'll quickly sum up all the basics here and start at the data science part. So now for the dictionaries. So dictionaries, if I go with this is a very important, you can say very important data type because this plays a very huge role in the data science fields for making out data, right? For making out the data sets. This is very important. Okay. So let me explain you this dictionaries with example. Okay. So let's say I'm guessing that you guys know about this Aadhaar card, right? For those who don't know, what is it, right? It is nothing but a unique ID which has been given to all the Indian citizens. So for every Aadhaar number, there is a name, or you can say a few details are there over the in your Aadhaar card, like attached with it. Okay, so now you can consider the Aadhaar card as a key, right? And the person details there as a value attached to that key, right? So dictionaries also work as the same thing, right? Dictionaries work on the basis of this key value pair, right? There also we are having some keys and some of the values, right? Similarly, so let's say now dictionary, if we define on the dictionary, so this is a collection of the data types where you are having this keys, okay, and the values. Now the values will be the index values, or you can say these keys will be the index values of this particular values what you will be writing on, right, for the KV pair. So let's say, let's make a dictionary. So let it be a dictionary and this name as so that should be key value. Now the important thing, one more thing, that like in the sets we were not repeating up the elements, the same will be in the dictionary, right? Okay, so in the dictionary you will not repeat the keys for the same time, right? If once you have declared a one key, then you will have to make something another key, right? You can't make duplicate keys over there. Like if I write key 1, then I'll have to take a key 2 there. The values could be same, but the keys should not be there. Okay. Now see, what I have done is I have made two keys over there with some two of the values, right? So dictionary contains this key value pairs enclosed with this curly braces, okay, and this key and values are the separated. These are the values separated by a comma over there, right? You can separate up things for making up differentiation with this, okay, cool. So let's just run this and we'll see the type of dictionary name. Well, this is dict. Okay, nice. So similarly, what we can do, if we just want to see the keys of this dictionary, right? So we'll write this dictionary of the keys. Okay. Similarly for this, if you want to see the values of this, you can run for this. So what you're getting is, this is having some key 1 and key 2 as its keys, right? And the values are the value and value itself, right? Because the values are same, right? The keys are different, the values are same. Okay. Now let me write a common dictionary. Okay. Let's say this is name and this is Chris. This is, let's say, age. So let's say 25. Okay. I'm just printing this text. Would I see this name as Chris, age as 25, right? Okay. Now let's say if I just want to see what are the values of this dictionary, so I'll find it to be Chris and 25, right? Similarly, you can write on many things over there, right? So in a dictionary, you have methods like clear, copy, values, update, right? You can even use this pop items, right? So there are a lot of operations what you can perform on a dictionary. Now, if we talk about for the operators in Python, right? So if we just are talking about the operations, then we'll go to study the operators in Python. Okay. So operators in Python, or you can say the operators are the constructors which can manipulate the values of the operands, right? So how many type of operators we are having in this Python, right? So we are having identity operators, we are having comparison operators, logical operators, arithmetic operators, we are having membership operators, bitwise operators, assignment operators, okay? So we'll quickly see one by one and we'll understand these things, okay? So arithmetic operators are used just to perform some mathematical operations like additions, subtraction, multiplication, division, exponentiation, like that. Okay, so let's say we are taking some arithmetic operators example. Okay, so let it be A Okay, so A and B to be 4 and 8. Now we'll perform some of the actions for them. Okay, so let's say A plus B, right? The addition, the subtraction. So these are the basics one. So we'll be going very quickly. Multiplication, division. Now when you see the division one, right, you are getting some float numbers over there, right? If you see the additions, the subtraction and the multiplication, you are getting integer numbers being multiplied by integer, and your final outcome is also an integer. But in case of this division, you are getting a float over there, right? And if you want this to be also an integer value, you will have to use another operator that is called as integer division, or you can say even as the float division. Okay, so that is double slash. Okay. So let's run this and find it to be 0, right? Okay. Similarly, let's say this A multiplied by B. Now this will give you the exponent value of A to the power of the B. Okay. So that will be 65666. Okay, let's take something small. So let it be 2 to the power of 3. That is 8. Okay. 5. So this you can do with these things. Okay, these are the some of the common operations you perform on these arithmetic operators. Okay, you can also find the remainder, right? If you just divide something, let's say 10 divided by 5. So what you will get the remainder is 0, right? That is completely divided by 5, right? 10 is completely divided. But what if a number is not divided, completely divided? So in that case, you will get a remainder if you use the modulus operator over there. Okay, fine. So we'll see the comparison operators. Okay, so comparison operators are used to compare up the values on either sides, right, for the LHS or the RHS, right, and then decide the relation between them, right, whether it is equal, so you'll be getting a result as true. If it is not an equal statement, then you will be getting the result as false. That's very simple. Okay, so these are the working on the comparison operators. Okay, so let's write. Now we know that A and B are 4 and 8, right? So if we just say, okay, let's take some different values. It will be A equals 10 and this B equals 20. Now, if I say to print A equals B, right? So if I use this operator, this equals to operator, we'll find that if these values of these two operands, that is A and B, if the values of both the sides are equal, we'll be getting a true outcome. That is false now, right? Because the values are not equal, right? If it is equal, if I say this 2 is equals to 4 minus 2, that is a correct statement, right? Okay. So similarly, like this is for equals, then we have something for this not equals. So not equals is like A not equals to B. So this is also a correct statement, right? Because we are writing A is not equals to B, and we know that A is not equals to B exactly. If we run this, we'll get a true outcome over there, right? Now, some common are, like if you say this 4 is greater than 5, that is false. If you say 5 is less than 4, or 5 is, let's say, 10 is less than 30, that is correct statement. 50 is greater than equals to 100 minus 50, right? Now what this particular 50 is greater than equals to 100 minus 50 means, right? So this is like, see, this 50 is greater than equals to means that it will be checked for 2 times, right? Here are 2 operators used, so we'll be checking for 2 of the kinds, right? So we'll first see that whether 50 is greater than this particular thing or not, right? If it is greater, then it's okay, it will be true. If it is not greater, then it will be false, obviously. Now, if it is equals to this, also, if in any of the cases, if it is greater or either if it is equals, right? In any of the cases, if the outcome is true, we'll be getting a true outcome, okay? Right? So we know that 50 is not greater than this 50, right? But still, you are getting a true result because this is equals to 50. Similarly, you have 50 is less than equals to 50. That is also correct statement. Okay, so I think this would be clear to you guys. Next, we come up to see some assignment operators. Okay, so we'll quickly see these things, assignment operators. So assignment operators are used just to assign the values, and this is the very common operator we are using from the very first day, right? That is x is equals to something, y is equals to something. So this equals to is said has to be assignment one, right? That is an assignment operator. Okay. Now let's say this to be 50. That is 50. Now there is one operator called as add and, right? That is add and. Not this is add and. Okay. So that is working. If I say this x to be x plus 50 more, right? And if I print this x, what will the outcome, guys? That will be 100, right? Because x is 50 and we are adding 50 more to it, right? So that will be 100 obviously. But in this case, if I just remove this x plus and this equals, and if we just make a short thing, right? If we just make up a very short thing with this, and if we just write on that x plus equals to 50 and print the value of x. So what you will see, what is the value of x is for now? This is right. This is 100 for now, right? So whatever the value for x will be, it will be added up with the 50, and you will be getting the outcome over there. So that is 150. Fine. Okay. Similarly, you can perform for the multiplication, divisions, and all those things. Okay. You can go on and perform all those fine things. Okay. Now we'll quickly come up to see the logical operators. Okay. So logical operators in Python are of three kinds. Right? That is and, or, and not. Okay. Now and is, if we just define this and, so and is like true if both the operands, like whatever you are using, like if you see for this here, if both of the operands on the right hand side as well as on the left hand side, this and will be used if both of the operands are true, right? Or you will be getting a true outcome when you use this and only when all the, or you can say both the operands are true result, right? So let's say this is 2 greater than 3 and this is 4 greater than 5. Now we know that on both of the operands we are having a false result, right? 2 is not greater than 3 and also 4 is not greater than 5, right? So you're obviously getting a false result, right? So what I mean to say is that if your outcome on the left hand side is true and the right hand side is true, you'll be getting a true result. So only if this happens, then only you will be getting a true result. Okay. In any case, if you have a false statement over there and here as a true one, so you'll be getting false, right? So if only and only both the sides are true, you'll be getting a true result. Okay. Now there is another call as or, right? So or will print true if any of the cases becomes true, right? Let's say this is false and you are using with the or. So you'll get a true result. If any of the cases is true, you'll be getting a true result. But if it's false on both the sides, then obviously you'll be getting a false result. Okay. Now there is something called as not, right? So not is something which is the complement of the operand exactly, right? So if it is true, you'll be getting a false result. If it is false, you'll be getting a true result, right? So let's say you write not of true. So you'll get false. Similarly, if you write not of false, that will be true. Correct? Okay. Now we'll look on to the membership operators. So membership operators are used to test whether a value or a variable, you can say, is found in a sequence. And if I say it's the sequence, it means like it is whether it is found in the set or in a string or dictionary or tuples, or you can say in the list. If it is found there, then it would be true, and if it is not, then it would be false. Okay. So these are the values or the variables which are used to test whether something is there in the sequence or not. Okay. So let's just say that this is x and this is 1, 2, 3 and 4, right? This is 1, 2, 3 and 4. Okay, and you say a equals 3. Now let's see that if a is in x or not, right? If a lies in x or not. if we just print this, we'll get a true result because this 3 is in x, right? The 3 is existing in this x, right? Similarly, like in we have a different operator that is not in, right? So not in will return you true if you write a correct statement, obviously, right? So true if the value of the variable is not found in the sequence, right? So you'll get only true if the value or the variable you are writing is not found in the basic set, right? All the parents that you want to check on. Okay. So let's say we want to print a not in x. Now we know that a is in x, right? So if we just print not in, we'll get a false result, right? Because it is present. Okay. Fine. Now we'll try to see some conditional statements. What are conditions in Python, right? So conditions are like when you have some options to go through, right? So let me tell you actually how these things works, right? So in Python you have three kind of statements, that is if statement, elif statement, and else statement, right? So first in the very first thing, the control will check that if whatever the condition you are writing, right? First, if condition will be checked on, right? If it is correct, then it will execute the statements or like the if clause what you have written, it will be run on, right? So if it is not correct, right, then it will go to the elif one, right? It will check the elif condition whether it is true, and if it is true, it will be executing the codes over there, right? And if it is not correct there too, then it will go to else, right? So it is not compulsory to use elif in every of the code, right? It's not even compulsory to use else in every of the things, right? You can also go with the if also, right? That depends how you write other things. Okay. So syntax is like, if we just say for the syntax, so syntax are like, first you write if, then you write your conditions, right? Inside these conditions, you write your statements. Similarly, you go for this elif. So if this condition 1 is not correct, you go for a condition 2. And again, if this condition 2 is correct, you will be going on executing some of the statements. So similarly, if both of these are not correct, we'll go on in the else. And in this else, we'll not check for any of the condition. We'll just print on whatever it is written inside that. Okay. So that is the working of this particular if and else. Okay. Cool. Fine. So let's say if I just take an example. So let's say this is x equals 10 and this is y equals 12. Now you're saying if your x is less than y, right? If your x is less than y, so what you'll do is you'll print something over there, right? You'll just put a colon and then you'll write print, and then you can write that x is lesser than y, right? The next what you can do, if your x is equals to y, you can take x is, or you say x equals y. Similarly, you can take up the else and you can write x is greater than y. Sorry, if it is not lesser, if it is not equals to, then obviously it will be greater, right? So that is, you'll be getting a greater result, right? So if you run this, you'll see an outcome that is x is less than y. Now these conditions can be used in many ways, right? So yesterday I said you guys that how to just check on the things like how to get a OTP, how to get some random things over there, right? So we'll be using one thing over there. Let's say there is a person, right? He's trying to log in his Gmail. Okay. So like we'll take an input first and we'll write enter your Gmail, right? And let's say you have the Gmail of the person xyz at the rate of gmail.com, or let's say to be abc at the rate of gmail.com. Cool. So how we can put on the conditions, right? We can say that if, okay, let it to be capital G. So we can say this, if this Gmail lies in this Gmail, right? The membership operator will apply that if this Gmail, what the user enter, if it lies in this Gmail, then we'll say to enter up the passwords, right? And we are not going to check up for all these things now. Okay, I'm just giving a glance of how this thing works. So just write up the passwords over there, and that is print welcome. Cool. Now what if it is not there, right? We can just directly take else, and here we can print email does not exist, right? It's very easy. Just run this and it will ask you to enter a Gmail, right? Let's say if we write any different things, right? If we just write of any else things, let's just write it that to be so that is email not exist, right? Exactly, it will not exist. So if you see your Gmail, what was your input? So this was your input, right? And this not exist exactly in this list, right? So this is a very common method what everyone does, right? But what is the method behind if you want to exactly check, like we are taking for a Gmail, right? And I have entered the domain as for theeks.in, right? That is exactly incorrect, right? So how to resist the user up there, right? So what you can do is you can use split there, right? Split with @, and in case of these things, what exactly how these companies store these things, it will remove up this .com, the gmail.com, it removes these things. Okay, it only takes the username you are using. Okay, so now you will do, if the Gmail of the 0 is in Gmail, will print this, and else it will give the email does not exist. So again run this. Let's say even if I write this workshops at the rate of gmail.com, it will give email does not exist. Understood? Why? Because if I see my Gmail, I'll find it to be workshops and the other side has to be gmail.com. So this username is not found inside this list over there. Another thing what you can do is, you can find this if the Gmail is not equals to gmail.com, right? That is if the Gmail of -1, if the last part, right? That is the last part, right? If the domain, because whenever you write your email, the last part is always your domain, right? And if a company wants to reset some, if only with its own domain, what you can write is that if you are using gmail.com over there, then it's fine, right? If it is not, if it is equals to this, then it's fine, right? If it is not equals, then invalid email. So run this. Now let's say xyz at the rate of yahoo.com. So you'll see invalid. Why? Because you'll see it to be yahoo.com over there. And we say that it should be always gmail.com, right? So it can work like that. We just run this and let's say xyz at the rate of gmail.com. So enter password. So you can write anything, let's say cool, and it is welcome. Okay. So these things can be worked like this. Okay. Now we'll come up to the loops quickly. Okay. So statements, like you see, I think you are clear to these things, right? So we'll come up to the loops quickly now. Okay. So in general, statements like these are executed sequentially, right? The first statement is a function, like in what if we focus on the loops. So first statement is a function which is executed first, and then it goes to followed by the rest of the things, right? So a loop statement allows us to execute a statement, right, or a block of codes or a group of lines, you can say, right, for a many number of times, you can say, right. So let's say if we just write on the code. So first what will happen, see, first you will be getting a control statement, right. If it is true, it will be going inside a loop, right. You will be executing the same thing for the number of times you want, right. So how many kind of loops we are having? So we are mainly having two kind of loops. That is infinite loop. Okay, infinite is nothing like when conditions will never become false. That is a infinite loop, right? What is a finite loop? At one point, when your condition will become false, then the control statement, right? The control statement will move out of the loop. That is your finite. Okay. So based on this, we'll categorize loop, right? That is while, for, and nested. Okay. Nested is something where you have loop inside one loop, and for is like you where you know how many number of times you want to execute your codes, right? And while loop is here, first condition is checked, and if it is true, the control will loop, right? The control will go on looping the things and executing the statements over there, right? So we use this while loop exactly when we are not sure how many number of times we want to execute a group of statements, right? Or you can say that when we are unsure about the number of iterations we want, then we use while loops. Okay. So let's just take anything. An example, let's say this to be count equals 0. And use this quickly while. Let's say if I'm writing this count is less than 10. So until this count becomes less than 10, we'll be printing this count value. Okay. And after every print, what we'll do, we will initialize this count. We will increment this count by 1. Right. So once it is getting printed, then its value to be like once the 0 is less than 10 will be printed out, right? Then it will be added up with this 1 and it will be coming like 1. Similarly, it will go for 1, 2, 3, 4, 5. Okay. So after this done, what we'll do, we'll come out of the loop and we'll print goodbye. Right. Run this and you can see, right, like until and unless this count was less than 10, right, as soon as it becomes 10, it came out of the loop and it printed goodbye. Okay. Hope it is clear, right? So similarly, like in the for loop, like we use while loop. I think it is clear to you guys, right? And the for loops, like the while loop, this for loop also allows, like you can say, a code of block to be repeated for a certain number of times, right? But the only difference is in for loop, we know like how many amount of iterations we want, how many number of times we want to repeat some things, right? So there we know these things. Okay. So it totally depends on your conditions and number of iterations you are giving there. Okay. So you'll get a better idea if we just look over the example. So let's say we are having some fruits and these are say to be let's say to be grapes. Right. So these are fruits. Now instead of printing these one by one, right? Instead of just printing these one by one, what we can do is we can apply for loops and we can get all these things, right? So if we just write that for index, right, in this range of the length of this fruits, want to print the fruits of index. What will get? The elements, right? That is banana, grapes, and apple, right? Instead of writing these things, you could have just written it like for x in fruits print x. That is also the same things. Okay. So this is like how for loop works, right? Instead of printing one by one thing, you can just go on and make a loop over there, right? Similarly, we use nested loops. So nested loop basically means like there is a loop inside one loop, right? It can be a for loop inside a while loop, or it can be a while loop inside a for loop, right? Even a for loop can be there inside a for loop, and or a while loop inside that. Okay, so you can have all these PNCs, permutations, combinations over there, right? So you can apply those things. So let's say this count to be 1, and now we'll be looking on some for the nested list. So for I in range let's say for I in a range of 10, we'll go, and this printing will be the str of this I multiplied by I, right? So what will be the outcome? We'll see it, okay. But before this, just like one more j in range of 0 and I, okay. And here will initialize this count to be incremented by 1. So we'll run this and we'll see some outcomes. That is 1, 2, 2, 3, 3, 4, 4, 5, 5, and something like this, right? So inside one loop, right? Inside one particular loop, you have generated this for the number. Let's say if we just remove this, run this, and you're getting something like this, right? Understood. So run. Okay, some indentations error. So run this, you'll get the outcomes. Okay, fine. So now we'll move quickly to the next topic, right? That is how you make inputs and output in your files, right? That is file handling topic. So Python has built-in function that is open. When we work in the file handling, that is open. A built-in method is there, right? Top to open the file, right? So this function returns a file object. Also, you can say it to be handle, right? It handles some file object. So it is used to read or to modify the file accordingly, right? We can specify the modes over there. Like what are the modes? If we just write down, if we just see the syntax of this. So first you write the file name, what you want. Then you write out the extension of this. That should be txt. And then there comes the mode. Okay. This mode can be R, which is said to be read. This can be W, which is say write. And this can also be A, that is append to a file, right? So we can apply these things over there, right? Okay. So let's say it is to be F. Okay. Now let's say you want to read something over there, or you want to open up something. Okay. So let's say this to be open, and let's write we want to open this things.txt, right? Now, if we don't write any of the things over there, right? If we don't write R or like the things over there, right? If we don't define these modes over there, so what will happen? Okay, nothing will happen over there. If you just run this, you will get an error over there, right? And why this error? Because file not found. Because we haven't made any file with this name, right? So you'll get the errors over there, right? You'll get the errors over there, right? So what to do now? You can manually make some files over there, right? You can manually make files. But if you don't want to make manually these files, what you can do? You can use some modes over there. You can use this W, right? And run this. So this time you will not get any errors, right? Because when you use this mode of W, what happens? Even if the file is not there in this whole system, right? It will create a file with that particular name what you have written, right? And then you can read on these things. You can actually, this W stands for write, as I said, right? So you can use these things, okay, for opening and closing and all these things, right? For reading a thing, you'll be using this R. So this time R will be working on, right? So that is the criteria of how you work on, okay, in this file handling, okay. And if you have opened any file, if you want to close it, then the simple thing is like, after working on the file, write F equals to what is the file you have. Okay, let's just write it here itself. So let's just write F dot close. That's it. Okay. Okay, just write F dot close. You can see some doubts over there. Why two loops are there? Okay, let me see. This can be done with one particular loop. It's not necessary over there. I was just saying you like how you can use these things. This can be done with one. Let me see these things. Yes, Vishal, it was by mistake. In which folder file should be? These are stored in your local host where you use this Jupyter's, right, in your files over there like this. Okay, cool. So now we'll quickly move to the modules. Okay, so Python has a lot of modules, as I said. You have date time, you have randoms, you have functions too there, right? So okay, let's see the random module. I see that I'll discussing it yesterday. Let's do it today. So random is such a module, right, in this Python where you can generate some numbers over there, right? This functions in the random module generate a pseudo-random number, you can say, like using some random functions which generates a float number from 0.0 to 1.0 exactly. So if you just say this has to be imported up, so import random, and then just print on what you want, print random dot random, run this. So what I said, the range is always 0.0 to 1.0. Okay. Okay. So similarly, like this random will generate some numbers. Similarly, there is one another module name as math, right? So in math module, like you can just do some of the important mathematical functions over there with the help of that. Let's say if you are using this math module, again you have to import this. So let's say you want to find the pi value, right? So that is math.pi. So you get the pi value over there. Okay, understood? Okay, fine. Moving on. So you can just find out the square roots even, like if you just want to find the square root of, let's say it's to be 64.64. So that is the value 8.0. So math can be used to do some mathematical calculations over there. Alright? Yeah. Moving up. Now we'll quickly see some different module that is like date time. That is very easy, very interesting also. This is widely used actually. Okay. Now this date time is not a type of its own, you can say, right? We work on this because this is used as a module in Python, right? So it shows how you can use the varieties of dates and times structures in this Python, right? So let's say if we just write this import date time and just print date time dot date time. Let's go for this now. So you'll get the current date, that is in the format of year, then the month, and then the day. Even the time, that is was the hour, minute, the seconds, and the microseconds. Okay. Yeah, it should be clear. Okay. Moving on. Now we'll see two OOPs, right? This OOPs refers to the object-oriented programming in Python, right? So Python is not completely object-oriented as it contains some procedural functions over there, right? So you must be wondering what is the difference between a procedural function and object-oriented programming, right? So to clear these things, actually students have doubt on these topics, right? So to clear these, we'll just write a couple of codes and we'll see that, right? So we'll see the Python classes here and we'll focus on that, right? So class in a Python is, you can say, a blueprint from which specific objects are created, okay? From where these specific objects are created on. So it lets you structure over the software in a particular way what you want to create, right? So here comes this questions will arise to you, right? That classes allow us to logically group our data and function in a way that is easy to reuse and a way to build up upon if needed to be, right? So using a class, you can add consistency to your program so that they can be used in cleaner and efficient phase, right? So the attributes are like in the classes are the data members, like the class variables, instance variables, okay? So class variable is a variable that is shared by all the different objects or instances in a class. And instance variables are the variables which are unique to each instance. So it is defined as a method to belonging to the current instance of the class, right? So let's just take up examples over there and we'll come to it. Okay. So let's say we are taking a class of employee. And this is pass statement, right? So this pass actually does nothing, right? So this is the null statement. So now we'll give number. So let's remove this pass, let's write things over there. Let's say the attributes and the methods we are going to write on. Cool. So let's say this is employee 1 and this is employee 2. Okay. Now we'll create instance variables like manually. Okay. So like the first, okay, this is emp underscore 1, right? So if it is like the first thing you want to write on there, the first attribute, so we'll be writing first. So the first employee, right? The first employee name, let it be Samuel. Okay. And the last name. Okay. So let it be John. Cool. So similarly, just take the email. So these are the attributes you want to create on. So smjohn@gmail.com. Okay. Similarly, you can write emp. So let's just write its pay scale, right? What he's getting as his payment. So let it be so let these to be his payment amount, right? So like this, you can similarly create some seconds too. So let's just write to be pasted over there. So this to be the second one. And let's just change these things. So let it be so let it be John Abraham. Email ID that's changed. So okay, and let's just change the space case too. Right? Fine, cool. Run this and employees not defined. Okay, we got some errors. EMPLYOVE. Okay. Where's the happening in the line number? First. The third line is having EMP equals EMPL. Oh my. Minus is plus. So let's just write it up quickly. So like you can just make it as a class if you want it to be employee. Okay, like you can write it, this is your class name, right? So let's just write it to be class employee, and let's say this was to be this on this, right? So like let's say this is your class, right? And you want to make some objects with this. So like p1 equals to your class. So this is your employee, and you can even print this as p1 dot e first. So you'll get your like outcomes over there, right? There in this one we'll have to mention the def, right? You'll have to mention it for the classes. Okay, so we'll do that. So like let's say if you are making it as the class, so here in place of, let's mention this. So done. Anything more? Yeah, this one has to be moved, and it's this comma error. Cool. Now you can quickly check up the things with this. Like you can print the things like, let's say to be enp dot, or let's say this to be one dot email. We haven't defined these things. Okay. Email is not defined. You just write email. empl2. Okay, we'll see it. Just not to waste up the time for now. Error over there something. What was the error over there? If we just see on. Okay, we'll do in the last. Okay, fine. So now to move on. So like we'll be starting up with the data science part. Okay, which is very clear to you guys, right? I think the basics are clear. We'll do this class one in the last. Okay, like in the random, what we use in the random, what you can do with the random things, because random, as I said, are very important, right? That is, if you like use these things, let's say this is a code, right? And you use random, and from there, let's say we are using this rand range or rand int. So rand range of some numbers over there, let's say to be some 6-digit numbers, and here to be something 6-digit. Okay, so this will be the numbers ranging from 1 2 3 4 5 5 to this 90784. Okay, understood? So let's just say this is your code, right? And you just want to print with this G and this to be the str of this code. So you can just print on like this. This is your you run this, you get an outcome, right? Because like what is there exactly, that is the code, which is your random generated value. That is g dash your value, what is randomly generated. Okay, that is randomly generated value is your, then the last part is your write the rest of the strings what you have written, right? So those are the basic things, right? Now we'll try to understand the data science part. We'll start up with the NumPy area. Okay, so what are NumPy, right? So NumPy is a Python package that stands for numerical Python, right? It is a code library for the scientific computing, like which where you can use the powerful n-dimensional array objects. Okay, you can use up there the things too. So let's just start with the NumPy. So now, where these things are used actually, if we just focus on like where these NumPy are used. So NumPy basically provides you the tool for integrating the C, C++, and the things like that, right? It is also a useful module in this linear algebra or the random number capabilities. Okay, so NumPy array can be used for an efficient multi-dimensional container for very generic data types, right? So what is like when I'm saying that this is NumPy array or NumPy Python NumPy array? So what are these things, right? So NumPy array is a powerful n-dimensional array object which is in the form of rows and the columns, right? That is also an n-dimensional one, right? So we'll see quickly the things. So first of all, how to install this NumPy, right? If you are using the Windows, or like if you are using another IDE over there, so you'll have to write it to be pip install NumPy, right? Other than if you are using Jupyter, it's very cool. You'll write import NumPy and let it to be as np. Okay, so import it like that, right? We'll just go with the star and we'll come over there. Okay, so how do we start with the NumPy, right? So let's see how we can implement these things. Okay, so in NumPy, as I said, that there should be an n-dimensional figures over there, right? So we'll start up see the single dimension things, right? How the dimensions are defined. So let's say this is a single dimension array. Let's say to be A. And let's say to be 1, 2, 3. And just print your A. So what you come to see that this is in NumPy array. If you just check the type of A also, just print this A. Type of A. So you see it's a NumPy ND array, n dimensions array are there, right? And you're getting from 1 to 3. Now if it says that n dimension arrays are there, so what is exactly the number of dimensions you're having, right? What exactly the number of dimensions you're having? It is not ND1, right? So how many dimensions is having? You can check it by a method called as ND, which stands for the number of dimensions there are in your arrays. Okay. Okay, so run this and you can see this is one dimension, right? One more shortcut is like you can say for identifying the number of dimensions of your array is like you can find for the number of the square brackets starting from, right? So that is if the number of brackets or if the number of square brackets are found to be 1, right? If it is found to be 1, then obviously it is one dimension figure, right? You can use with that too. Okay. Now, just say that we are making a two-dimensional, right? You can say exactly in the NumPy, you have one as single dimension, and if it is not a single dimension, then it is a multi-dimension, right? So let it be 2D, 3D, 4D, anything, any dimensions we are making on, it is obviously the multi-dimensions if it is not a single dimension, right? So let it to be np dot an array, and let this to be 1, 2, 3, 4, 5, 6. Cool. So now if you see, the A. So we'll get the output as 1, 2, 3 and 4, 5, 6. Right? So here it stands that you're having some two dimensions, right? If you see also the brackets, you're having some two brackets in the starting. That means that it is two dimension, right? So if you just say, so we print A dot and div. So that is two dimension, right? Okay, cool. So these are the dimensions actually. Okay. So now what if and we define an array with no dimensions, right? You want to define something with no dimensions, right? How to write that? It's a very basic thing, right? If there is one bracket, it's one dimension, two brackets, two dimensions. So no brackets, no dimensions, right? Easy. So if we just write on np.array and let's say to be 45, print c dot ending. So you'll get 0. It's 0 dimension. The type of C is an ND array. C is 45, array of 45. Okay, so it is 0 dimension one, right? So that is like a 0 dimension how you define those things, right? Okay, nice. So moving ahead, so you have seen single dimension, you have seen how to write the multi-dimension and find out the things, right? So like many of you always want, right? You will be thinking on, right? Why do we use this Python NumPy if we have the Python list? Because these are very similar to list, right? Here we just see on the things. These are very similar to the list. So why we are using this Python this NumPy array, right? So let's understand this thing with an example, right? So if we just compare on this Python NumPy with the list, right? There are a difference. Like we can say this NumPy is faster as for the memory. This is very efficient in the memory purpose. It is very fast and it is very convenient to use, right? Now how? We'll give you a briefing with the codes over there. So let's say we have to import the shifts and the time modules. Okay. Let's say this is S, which is a range of some 1000 numbers. Now, if you want to get the size of any element, right? Any element, there is fixed for the number of integers, or it is fixed for the number of float you want to check in, right? So let's say you want to find like get the size of 1, right? The size of 1 would be, if we just print the size of 1, it is so this is not sorry. This is get size of. Okay, so the size of 1 is 28. Okay, that is 28. Why? So let's see the size of 2. This is also 28. So in every case, let's say this to be 2000. This is still 28. So the size of an integer is always in the 28 bytes. Okay. If we go up with the float values, this will change to 24. Right? This will change to 24. Okay. Similar for the complex, it's different. Okay. For the strings, it's different. For the strings, it depends on like how many number of things are there, right? So whatever the size of this one particular element would be, if we just multiply it with the length of whole of the S size, the length of the total S, we'll get the total size of this list, right? This range of 1000 numbers will be inside the list, right? If we just write on multiply these things with the length of this S, we'll get everything out there, right? Now let's say with D, and this is an arrange of again the 1000, right? We are taking the similar things out there. And now in the NumPy, what happens? If you want to see the total number of elements present inside your array or inside your NumPy array, right? So what you do is you find it to be with the size. Okay. So like similar, we use the get size of one particular element. Here we have an option to find it for the item size. Okay, that is item size in this NumPy. So item size multiplied by the total size of the array. Okay, we don't have to define it with the length of these things. Okay, we can just simply write d dot size, right? This defines you the number of elements present inside your NumPy array. So if you multiply this item size with the size, and if you run this, we'll get two outcomes, that is 28,000 and 8,000, right? Understood? It is this list is storing 28,000 bytes for storing this 1,000 numbers, right? But in case of the NumPy, it is only storing 8,000 bytes, right? That is nearly 7 times like larger than this list. Okay. Now, if this was the first thing, right, you can define it on the basis of the size it is taking up. Now, if we just define it on the basis of the time, right, if you just see it, how much time it takes to execute these things, like, so let's say this is your L1, which is a range of, okay, before that, let's just define some good numbers. Let's make it some shorter. So this is a range of this S, and this L2 is also a range of this S. Okay, so these are the L, that is a list. Let's take the arrays. So this to be an arrange of this S. Okay, and here, now this is, as this is an array, so we'll be writing on A range, that is an arrays range. Okay, so A2 and these things. Okay, now we'll see the comparison in the time execution. Okay, so let's say this to be the start, and the start is, let's to be time dot time. So you need to import this time here, and also we'll be using the sys. So if you don't use the sys, that's okay. So let's take this time dot time over there, right? And we want some of our results. So the result would be, that is what we will be going to do on, right? What we'll be performing on. Okay. So here, let's say we are taking this X and Y, right? And we apply this for X comma Y in the zip of this L1 and L2. So it will combine all the values of this L1 and L2 and will give you the values over there. Now, our main agenda is to print out the time, that how much time it is taking to do this task, right? So the time we started up, right, for the current time minus the time it started up working, right, and that to multiplied by the 1,000 to get the exact milliseconds over there, not to the microseconds. Okay, so this will write for the same thing. Let's copy, paste, and this here is one bracket missing. So this is your start again. Okay, now here you will not have to write the loops over there. You can just quickly write A1 plus A2. But this you can't do in the list, right? You can't just write to add up the ranges. That is not possible. Okay. So just quickly run this. Any errors? Yeah. So you can see the difference, like you are having some 719 microseconds to run this list one, and you are getting 137 microseconds to run this NumPy one, right? So that's the basic difference. Okay. Someone asking what is size? Okay, cool. So size is the number of elements present inside your arrays, right? If I say it like that, let's say you are making A, and that is a NumPy array, and this is many times you would also see that these are written in the tuples. There is no such difference in that. So let's say this is my A. Data type not understood. So we missed one bracket. One bracket in the sides. Okay, so this is in A. Fine. Now, how many number of dimensions it's having? That is 2, right? What is the size actually, right? You're asking what is the size. So size is the number of elements we are having there, right? So if you just write a dot size, that is 6. That is we are having 3 and 3 here, right? 3 and 3 here. That is the 6 elements over there, right? Now what is the item size? The item size would be the individual size of the atom, the items, right? That is 8 bytes, right? And why it is 8, I'll briefing you, right? Don't worry for that. What is the data type of this? What is the data type of this array? Right? So that is a dot the d type. I'll get the data type. That is integer of 64 bits, right? That is fine. Now the item types is defined on the basis of the data type you are using, right? Now, if I say that the item types are defined on the basis of the data types you are having, right? That states that if you are using a 64 bytes, so you are getting the item size as 8, right? So that is like 64 you are having. You divide the 64 by 8. Whatever the data type you are having is, you divide it by 8 and you will get the item size over there. So just run this and you will get 8.0. That is your item size. Now let's say if you have any data type with some different item names. Let's say it should be let's write up these things. Let's copy and let's just say here that the D type you want is np dot float of 64 or 32 or 60. Okay, so like if you see your D type and the name of the data type, it is float 16. Okay, float of 16 bits, right? So what should be the item size of these elements now? If I see the item size, divide by 8, it would be 2 bytes. Understood? That's the basic criteria for defining the item size. Okay, so you can calculate the byte size of these things, right? Okay, now the data type is clear, item size is clear. Okay, now let's make some matrix types over there, right? So let's say this is X. This is 1, 2, 3. Okay, it's 4, 5, 6, 7, 8, 9. Okay, so if I just print on my X, I'll see something it to be 1, 2, 3, 4, 5, 6 and the 7, 8, 9. Okay, now if we just look on and just print the shape of this, so we'll get that there's one particular element, one particular array. Inside that you're having 3 rows and the 3 columns, right? That is 5. Okay, now if I want to reshape this, right? If I'm having this one, okay, let's just say if we just remove this from here, if we just cut up the things and let's just remove one from here and from here and also from here. So the size of the X would, sorry, the dimensions of the X would be 2, right? And X would look like something 1, 2, 3, 4, 5, 6. That's fine, right? Now, if I see the shape of this again, so it would be 2 cross 3. That is 2 rows and 3 columns. Okay, you're having 2 rows, and inside that 2 rows, you're having 3 individual elements in every particular thing, right? You can say 3 columns are there, right? So, if we just want to change its shape, right, that is like the transpose you can say on, right? What, not the transpose exactly, you just reshape this, right? So, what you'll write, you want to reshape this X and you want to reshape in, like this is 2 cross 3, right? And you want to reshape this in 3 by 2. Okay, so if you say you want to reshape this in 3 by 2 and you run this, I'll get an output with a reshaped one, that is 1, 2, 3, 4 and 5, 6. If we just compare up the things over there. Okay, so similarly you can do slicings over there in your arrays, right? If you just write it to be X, which is np dot array, So this is 1, 2, 3, 4 and 3, 4, 5, 6. Okay, let's run this quickly. And now if I say, if I want to print the x of 0 to 2, so we'll get the outcome as 3, right? That is very easy. The 0 of 2. So 0 of 2 is 3, right? So like this, you can index up the things in your arrays, like it's the basic indexing you're having on there, right? Okay. So moving up more. So now see guys, if you have an array, right? Many times this question comes like in the interviews too, right? If you have an array and like you're having a 4-dimension array, 3-dimension array, 2-dimension array, any kind of array, n-dimension array, and you want to just make it in 1 dimension, right? You want to just reshape those things in 1 dimension. What you can do is you can do it to be -1. You can write the reshape of this -1, you will get the values over there, right? So let's say this is your x, which is having a dimension of 2, right? But you want all the elements, if you see your x, this is your x, right? You want all the elements to be printed inside one particular list, right? So in that case, what you can do is, in that case, you can write x dot reshape, and you can reshape to any negative values. Let's say -10, -19, anything. So you'll be getting a single dimension array with that, right? Okay. Now, fine. So there are various functions over there to reshape in one particular dimension. Okay? I'm not going with those things, right? Now let's say you are having an array which is having some numbers, right? And you want to find the maximum and the minimum from those things, right? So let's say in this x, you want to find the maximum number from this array. So what you can do is, you can directly write this np, or you can just write it to be print x dot the max value. Similarly, x dot the min value, x dot the sum value, right? You can out things, right? That is the maximum to be 6, minimum to be the 1, and the sums to be 28. Okay, nice. So we will see now the data distribution parts, right? Now we'll come up to the data distribution and we'll see how these things works over there, right? Okay. So the very first thing in the calculation part is linspace, right? What are linspace? So this is like another operation in Python NumPy which returns you the evenly spaced numbers over a specified interval, right? Over a very specified interval, it returns you the evenly spaced numbers, right? Okay, let's see. So this will be x and np dot this linspace. Now linspace are nothing less like you have to first define your starting number from where you want to start. Then you have to define your ending number where you want to end up. And then if you don't define anything there, let's see what happens. So let's say we want some numbers between 1 to 30. Okay, we want numbers from 1 to 30, right? And by default, it will give you some 50 numbers. So if you see your x, it will be by default some 50 numbers over there between 1 to 30, right? And this will be exactly in an evenly spaced type. Okay, so you'll be getting an evenly spaced things over there. Now, what you see is that you are getting the equal space numbers from 1 to 30, and that is by default we are getting some 50 numbers, right? Now, if you define your numbers over there, then you will get the exact number of that kind. Okay, right? So this is your x, right? And you are getting some 50 numbers over there. If you just see the length of this x, you'll come to see that this is 50. Okay. Now what if you define a linspace? So let's say you want the linspace from 1 to 100 and you want only 10 numbers. So you'll get the numbers with the equal spacing. Okay, that is 1, 12, 20 and like that. You want from 0 to 110 with that. So with these things, you will get an equal spacing out with the numbers you'll write over there. Okay. Now if you want to see like what are the spacing which is using this linspace is using, so here you can write, you want to return the stepping, that should be true. So it will return you stepping value, that is it is using 11 point this much, this one terminating over there. So 11.111 in every of the number to add it up, and then you are seeing the next values, right? So red step is your return step, right? You are getting the step return with that. Okay. Divyani is saying set size is not clear, sir. Data size, item size. Okay, cool. So see, if we are having x and you're having all these things over there, if I say x dot size, so this is the exact number of elements inside this array. Okay, so we are having 50 elements. The size says that there is 50 elements. Now, if you see the data type, the x dot this d type dot this name. So the data type is float 64. So item size are the data type divided by the 8. Okay, so that is float 64. So 64 divided by 8 will be the item size of this x. That is item size. So individual items are having a size of 8 bytes. Okay, and this size x dot size will say you that there are the total number which are present inside that, right? This is 50 particular individual elements present inside this array. Hope this will be clear to you. Okay. Moving up next. So this you can see like the linspace. Now this linspace even works with the very smallest to smallest numbers. Like if you just write on that, you want a linspace between 0 to 0.1, or you say 0.01, and you want some 200 numbers between that, right? Even if you write with this, right, you want some numbers from 0.0 to 0.01, right, or 0.001. Even if you take any minute numbers over there, and you want some 200 numbers with that, run this, you will get 200 numbers, as you can see over there, right? So you will get some 200 numbers over there, right? So don't take these much less value. So this will take to be 0.0 to 4.0 and 200 values over there. So you will get some evenly spaced numbers and 200 values with that. Okay, I hope this would be also clear to you. Okay, fine. Now let's say like not to be printing these all 400 or 200 values. If you just want only to be, let's say this to be y or g, anything. Okay. So if you just want to see only the first 50 values, that is very easy. You can just write on this colon, and then you can pass on this 50 and run this. It will see the first 50 values itself, right? So like this you can write. Is it possible to specify step value for linspace? Yes, it is possible to specify, right? You can write on this return step, and that would be true. So you'll be getting these things. That is your stepping value is 0.201 and something like that. Okay, fine. So moving up next. Okay. So even you can find the same things for the log also. Like this is your x is you're having, right? Similarly, you can find the log space, and that would work the same as the linspace, but the only value is that you will be getting the logarithmic value over there. Okay. So np dot log space of y. So some single values, let's say. Oh, cool. Right? So like this, you can get the log spaces over there. Okay. Now moving up to the next thing. Now in in NumPy, like as I said, there are some n dimensions, so there are some rows and columns, and there are some x's to work on, right? So we'll see that how these there are differences with some related to x's, right? So let's say this is your a. print a dot the sum, right? And here, right, guys, okay, so here is like a dot sum, right? And you say x's to be 1. So you're getting 6 and 15, right? And why this 6 and 15? Now let's say this is your A. So your outcome is 1, 2, 3, 4, 5, 6. Now if you are finding the sum on the x is 1, so that is 3 plus 2 plus 1. That is 5 plus 1, 6. And next is 6 plus 5, that is 11 plus 4, 15. So you're getting 15 over there, right? Similarly, if we just print the sum on the axis of 0, so we'll get the values as 5, 7, 9, right? That is 4 plus 1 will be 5, 5 plus 2 will be 7, and 6 plus 3 will be 9. Okay, so I think you might have got it these things, okay? Okay, fine. So this is like how axis works, right? This is like how you deal up with the things, right? So let's say you're having this like array you're having, you make a copy with this array, right? That is a dot copy. So run this. Now if you see your B, you'll be getting 1, 2, 3, 4, 5, 6 as the same with what is it there in the A. So let's just change the B of 0 of this 0 to be 10. Okay. Now we'll see our B, and that is 10, 2, 3, 4, 5, 6. Okay. Right. So now this is your A and this is your B. Yeah. Now let's say you want to add something to B. You just say to be A plus B. That is added up, right? That is values are added up. That is 10 plus 1, if you just zoom out. So 10 plus 1, 11, 2 plus 2, 4, and like that. Okay. But what if I just want to print both of the arrays at once without adding them up, right? If we just want to combine those things, what exactly in the strings we say it to be string concatenations, right? So that is how we can do it. So here you have the functions called as concatenate to work on with that. Okay. So let's say this is np dot concatenate, and it actually takes one argument. So let's take with the A and B want to concatenate. Run this, you'll see a concatenated value over there, right? That is not added up. Okay. So you get up the things A by B. It is not added up there, right? Similarly, if I just write this concatenate on the axis 1, so you can see the things difference, that is 1, 2, 3. So it is adding all of the things in the row area, right? It is getting the additions in the row sides, or it is, you can say it is combining the values in the row sides. So by default, everything you get is in the column sides. Okay. So the column sides will be np dot concatenate this A and B in this axis of 0. So this is by default values for this arrays. Okay. I was asking numpy arrange, bin space same as arrange, want to specify the step. So you want to write it like np dot bin space between 1 to 12, and you want to say that step be like 3.4 or like that. So that is an invalid syntax, because red step cannot be there in this true or false, you can say, right? If you want to see, you can write a true, you can write a false. So in that case you can so in that case what you can do is you can write it, or either you can just write it to be let's say you just want it to be 10.0 like that. So you can, or you say it to be 5 numbers with step of 3.4 like that. So you can define it with this. Okay. Or else what you can do is, so let's say, but this will not come as exact values, right? This will not give you the exact values whatever you write, right? So let's say in that case you can take it with the arrange. So a range of, let's say, 1 to 12, and you want in the like the 4 intervals or 3 intervals. In that case you can write it to be there. right? Like that you can write. Okay, so this is the working of array. Arrange is nothing but the very similar things how range works, right? If you say it to be np dot arrange of some 1 to 100 numbers, and that too you want in the intervals of 5, so that will be 1 to 96, right? Okay, so next we come up to see, we have seen lean space, how will these work, we have seen the log space, how this works. Okay, so now we'll see the square roots and the standard deviations in this numpy, right? Okay, now let's say this is an numpy array. And you want to find the square root. That is a square root. Okay, data type not understood. The bracket setup. So these are the square roots. Okay. So similarly, let's say to be the arrays, or let's find the square root. So like the math module, like you can also find it, the things over there, like np dot square root of any number. Like similarly, maths module works. Okay. Okay. Now we'll see the standard deviation, how standard deviations works on. Okay. So standard deviations, you guys know. I think you guys know about standard deviations, right? So we can find the standard deviations too, right? That is sp.std mathematics sections. Okay. So the standard deviation of a would be the value like 1.70. Look at the standard deviations at that. Right? Similarly, you can even find the additions, the subtractions, the multiplications, and all those things, right? You can just multiply up the arrays, like let's say to be x, there is a, I think, a multiplied by b, and you'll get the values, right? Okay, so that is important things, right? Okay, now, so now we'll see very special functions of this numpy, like how to plot data with this numpy, right? So that is the special functions of this numpy. So here we'll be using one different mod package, that is matplotlib. Okay, so that is used for 2D plottings, 3D plottings over there, right? So we'll see this matplotlib also in a bit glance over there. Okay, so let's say, so after numpy we'll go on that. So import this matplotlib dot the pyplot as the plt. Now let's say I'm making this as an arrange of some elements. This to be 0 to 3, and let's say it to be multiplied with the pi, and I want the numbers in the interval of 0.1. Okay, so this y will be the sign of this x, and we just want to plot this up, like let's say we want to plot this x and y and just show this up, right? So you'll see a graph over there, that will be a sine graph, right? Sine graph over there with the x and y. Okay, so that is very similar, right? What we did is we did an arrange with starting from the 0, and we took it with the 3 multiplied by the pi values, right? And that to be intervals of the 0.1. So if you see your x, what are the values of the x? So x is the values of these things, right? So what you're having, you took a range of numbers from 0 to 3 multiplied by the pi value, right? So if you just multiply it by 3, so write with this to be np dot pi. So that is 9.424, right? Okay. It is 9.424, and you are getting the numbers from 9 up to 9.4 from the 0 to there, right? So you have written these things, right? So this is your range particularly, and in this too you want the numbers in the interval of 0.1. Understood? So if you just quickly write up the things, right? Np dot a range of numbers from 0 to 9.4 in the intervals of 0.1. So you'll get the same things over there as you got in the first one. Think that is clear to you, right? Okay. In the next line, we took it to be the sign values of x, okay, and then we plotted this, and then we show this, right? This show will use to just show your plotting what you have done. Even if you don't write, it will show you, right? But it's nice if you write this show function, right? It prints you the data or the plottings you have written on. Okay, so we got this, right? Similarly, if we take up with this different one, if we just say that let's this y to be the np dot the tan value of this x. Okay, so we are taking the tan values, and now this, if we say this plot x and y, and to show up this, so we'll see another graph, that is the tan graph, right? The graph versus of the sine graph and the tan graph. So we'll go in the matplotlib, okay, right? So we can use that, right? Okay. Now, similarly, you can even use the logs and all those things. You can even plot this thing to be, let's say, you say z to be np dot the log of, let's say, to the number 1. Okay, this is 1, 2, 3, and let's say z, which is a log, directly print it to be the log of a. So these are the log values, right? I think you understood, right? So if you would just want to see the log values with the base 10, you can just write on that np dot log of 10 with this a. So you get the log 10 values. Okay. So like this, you can cover up the things in this now. Okay. So like this, the matplotlib is very important with each of its steps to, okay. And one more thing, right? Relate on this. We'll use in the pandas. We'll use itself your data, right? You guys have, I have informed that you guys have filled up the forms in the Google Forms, right? And you know that in Google Forms you can just take out the data in the CSV format, in the Excel format right there. So we will be also doing the data structures part with even with your inputs, right? We'll see, like I was manipulating on your data, and I saw one name over there which has like given inputs for 10 times, right? He has submitted his form for 10 times, and like we'll be going on those data, and we'll see, right, how things works in the data structure. Doing it tomorrow, right? So now we'll be doing with the matplotlib and the Seaborn part, and going up with the NumPy, more other things, right? Now let's say if we take from this NumPy, import this random, right? If we just import the random from this NumPy, so there are the various things what you can do with the random. Let's say you take random of 5. So you'll get some random values over there. And again I say it's starting from 0.0 to 1.0. Okay. So you'll get some 5 random values. That is nice, right? Now let's say you are taking this random dot ran, and you are taking some 10 values, and then you are reshaping this into 2 cross 5. Run this, you'll get a 2 cross 5. So these kind of questions you'll be getting in your examination, right? Tomorrow, like tomorrow in the end, you'll be having an examination at 11 p.m. Okay. In those things, you'll be getting these questions like this. Okay. So prepare well with these things. After you pass the examinations, so those who will be passing the examinations will be given the links for giving the examinations of the IBM, and then we'll be getting the certification from the IBM. Okay, so you have to pass for the ethics examination before going to the IBM's one. Okay, fine. So like we can reshape of the things, even if it is a linear one, we can use this to reshape in 2 dimensions, 3 dimensions, anyone if we want to work with that, right? Okay. Now random has got very important one, that is choice, right? That is a choice one. So let's say if you want to write it as choice, okay, and let's say this to be 12, 30, 40. P equals to 0 0.5, 0 0.3, and let it be 0.2. The size equals to be, I'll deal what I'm doing, size equals to 50. Run this. So you got something over there, right? What it is actually, okay. So we have taken a choice function from this random, right? What it does actually, it will create an array of your choice, the numbers you will be giving on. Even if it is random, the numbers you will be giving on will be taking the numbers from there, right? So you're taking 12, 13 and 14 from this choice, right? From this random, you're only taking this 12, 13 and 14 from the, and you want only these to be printed out, right? So you have written your percentages over there, that is P equals 0 0.5, 0 0.3 and 0 0.2. That is 12 to be printed for 50%, 13 to be printed for 30%, and 14 to be printed for 20%, right? And then you have written your size, that number of elements you want with this much elements. So number of elements you are getting is 50. Okay, so that is you are getting 50 elements inside your array, and inside this array you are having 50% 12, 30% 13, and 20% 14 numbers. Right. So I think it would be clear to you, right? Fine. So similar other things you can find, you can increase your shapes, and you can even find more things over there. Okay. Now we'll go up to the matplotlib part. Okay. So we'll start up working with the matplotlib now. So matplotlib is a plotting library used for 2D plotting, graphics, and 2D graphics like that. Okay. So it is not also a part of like Python, right? It is a standard libraries which is installed by default, like when you install your Python, right? That is very installed like in the basics ones. Okay. So we have a lot of different kind of plottings inside this matplotlib. Like we have bar graph, we have histograms, scatter plottings, area plottings, pie plottings. A lot of things are there, right? So we'll see that how these things plot actually, how these things works actually. Okay. So let's say we have some height of the persons. Let's say 123. This is very less. Let's say 154, 176, 145, 187, 176. That's 135, 164, 147. Okay, some heights are there. Similarly, let's take some weights. So 43, 65, 28. This is very less. Let to be 40, 59, 47, 68, 73, 56. So 1, 2, 3, 4, 5, 6, 7. 3, 3, 6, 1, 7. 1 is left. That's right there. So that's okay. Now let's say we want to plot this weight and height, or height versus the weight. So you'll get a graph that is like exactly not a good graph, right? So you're getting something random points over there, and you see this is not well worked out, right? If I present this graph in front of anyone else, right? So that would be exactly not fine, right? So he'll not be able to like see like what is happening, right? He'll not be able to analyze of the things, right? Because it's kind of a messy graph, right? It's kind of a mess we are seeing over there. So that is like not uh, a good one to present on, right? So in that case, what we can do is we can just format these things, right? We can just add up some stylings over there, right? So what we can do is we will plot this and we'll write that height and weight to be plotted up, right? But we'll give some attributes to it, right? We'll say it to be plotted with right the red dots. O stand for the red dots, and then we'll run this. And now in this case, we can see some plottings, like as for the scatter plots, you can say, right? In that case, we can get some things with that reference. Okay, so that is also a good one to write on with those things, right? Okay, so here you can just analyze of your things, like this is your age, or like this is your height, so this is your weight, this is the height, then this is the weight, right? Here you can analyze these things. Okay, fine. Now you can even plot this as this height and this weight. Okay, so here you can also write it to be yellow dots, right? Even you can plot this height and weight with the lines itself. So let it be the red lines and this height and this weight to be given up with the yellow dots. Run this, and in this case you will again see a graph, right? What you get in the first one, right? In the very first thing what you got, you will again see this graph over there, but in this case you will see the points exactly you are having, right? So now you can just again, like you can just make up analysis, like if this is in height, then this is a weight, right? So this is not exactly done, right? This is not exactly the same things, but still you cannot. But I prefer that this is better than this, right? But this is not actually good, right? Because you can see the exact values, the exact ticks over there, right? So we'll see that one by one. Okay. Now let's say you have a graph and you want to plot these things, right? Like similarly, we plotted up this one, the sine graph. Let's take it this one. So we plotted this one, right? That is the sine graph we have. Now, in case if you just say that you want this plotting with some red dots, so you'll get a points over there like that, right? That is the individual points we are having on with the individual numbers of that, individual elements over there, right? So it is fine if you just take it with the blue lines. It is nice. So by default, whatever comes, it's nice, right? Now let's say you want to label on your graphs, right? You want to make some, x-axis like labels over there, the y-axis, the headers, right? For that reference, what you can do is you can plot the title of the graph. So let it be a sine graph. You can plot the x-axis of this graph, and this is x and y. So this is, you can write, these are the sine of x okay. Here you can just write these are the numbers, and the y-axis you can write this has to be the sine of the numbers. Okay, and then you can just show this, and okay. So let's write it to be labeled. Run this, yeah. So you'll get these things, right? Right. So Prabhat's asking, why do we write height and weight for twice? Okay. See, Prabhat, like when we first print the height and weight, once we have written this height and weight, this is for red, right? That R means that we want to print a red line. If we have nothing to initialize there, we have just written R. That means that height and weight are being printed, and you are getting some lines over there, right? You are getting some lines with that reference. And also, if you just write YO, that means exactly the yellow points, right? That is, these are the yellow points you're having. So you are first making some lines, and again on the same graph you are making some points over there. That is for 2 times we have written. So you can find the title, you can find the y-axis, you can find the x label over there, right? So I think that will also clear to you. Okay. Now in the plottings, if you want to just plot up the things, like if you go with the bar graphs, or you can say the bar actually, right? So how to plot with these things? Okay. So let's say we just want to plot a bar graph, this height and with this weight. So run this and you'll get a bar graph of that, right? So exact height and the exact weights over there with that reference. You can plot up these things, right? Even what you can do is, let's say we want a bar graph of this data. .25 cool, say 50, 40, 70, 80 and 20. Now we'll take the labels. So let it be BMW and let to be the width as t equals to p 0.5, right? So this is the first bar graph we are going to plot. In the second bar graph, slide it to be 0.75. G 20, 20, 30, 40, 40. It is linear, so let's take it at 60. It will be fine. And let's label this as body. Let's give the color here. So let's say to be the red color. And let's say we are taking a width of 0.5. The same width, right? And since we are using the labels, we have to plot the legend. So, well, the graph will be fine if we put on some labels to this. So let to be the days. The distance, the kilometers, the title. Let's run this and yeah. So you can see some data over there, right? Some basic manipulations, also some days versus the distance of some cars, right? So we have plotted a bar graph with some data and some labelings. So legend is particularly for you can say discriminating the things, right? Discriminating the graphs, the bars over there. Okay, fine. Moving ahead. So this is how you can plot a bar graph, right? Similarly, we can even print a histogram with that case, right? You can even print a histogram with all these cases. So let's say we are taking a population age, and let's just take some values over there: 22, 23, 56, 43, 76, 56, 98, 76, 87, 65, 45, 20, 34, 45. And so just let's take some of the ages over there, right? And now we'll take up the bins. Like these are the ratios in which you want of your values. 70, 80, 90, and 100. Okay. So let's print a histogram. And you just go and print it with the population age. Zoom in. Okay. So plot it with the population age and the bins. And hist type will give it as the bar graph we want. Right, and the width will be taking it to be, let's say 0.5. Run this and you will get a histogram with that case. Okay, so you can see how the numbers we are having. So we haven't taken any of this 0. So if we just remove this, then even still we can find out. So above 20, I think no such values are there. So 20 would be fine. Yeah. So this could like look as a good one, right? What does legend do? Legend actually plot up the things like the labels you are having in your graph. Like you are taking some two labels, that is the days, that is the Audi and the BMW, and you can just plot it. You can see the legends you are getting over there. So legend has also the locations where you want to plot it. Okay, fine. So this you have got the population versus this, and you can even write up the things over there too. Right, you can just write it as the X label. So these are the age groups, and the Y label can write it to be histogram. The title, or let's say the Y, write it number of people. So in the title you can write the histogram. That is fine. So that's nice. Okay. So okay. So someone is asking what are bins. So bins is like the number of the ticks you want, right? The number of labels. As see, we have written the 20, 30 and all these things. So you are getting 20, 30, 40, 50, 60, 70, 80, 90, exactly the same ticks you want. Okay. Okay. Fine. So now let's move it up. Now this is like how you can plot the histogram, and you see how you can plot up the bar graphs and all, right? Okay. Now let's say you want some scatter plottings also. So scatter plotting is very easy, right? You have seen in the first one, but that is not a scatter plot exactly. That is plotting with some of the points you say, right? Okay. So now let's see the scatter plots. So let's say you have x, which is might be having some values. So 1.5, 2.5, 3, 3.5, 4, let it to be the only 3.6. So 3, 3.5, 3.6. Similarly, let's take y, 7.5, 8, 8.5, 9, 9.5, 10, and 10.5. Similarly, let's take to be x1, let's take to be 8, 8.5, 9, 9.5, 10, 10.5, 1, 2, 3, 4, 5, 6. So one more value, 11. X2, or it to be y1. So 3, 3.5, 3.7, 4.5, 3.5, 3.7, 4, and if you what's the 4 over there. Yeah. So x, y, x1 and y1 clear, right? So length, if I just check on all the lengths, length of x, length of y, length of this x1, y1. So fine, all are of 7. Okay. Now, let's say it to be a scatter plot, right? So scatter plot between the x and y, and write the label. So writing label as high income, low saving, and giving the colors to be the red colors. Similarly, plotting the x and y, or this is x1, y1, making the labels as low income and high saving, giving the colors to be blue. Now let's make some labels on the x-axis. So let it be the saving multiplied by 1000. So as such for the y label, it would be the saving multiplied by 1000. Oh, sorry, the salary, income. Income multiplied by the 1000. Now in the last case, you can just plot on the title. That will be a scatter plot, right? And we'll show up the things. So that is a scatter plot, right? That is a kind of plotting everything. Okay, we forgot something. I think we made one labels. So let's quickly plot the legends too and see. So now you can see your legends over there, right? And now let's say many a time what happens, see, many a times you make graphs and that is not exactly of the, like many a times it would be there that the graph is not fitting, right? The graph is not fitting of the stages, right? It is not fitting of the things it needed to be there, right? So in that case, what you can do, you can enlarge your graph. How? You can write like in the figure, you want to set the fixed size to your extent, right? The things you want, right? Let's say you want 10 cross 5. Oh, shit. So that should be not exactly like this. So you can see your graph to be as a 10 cross 5. You can even make it to be 10 cross 8, and that could be a 10 cross 8 graph like this. Okay. So I suggest is the very best size is always 8 by 5. The good size, it is always a good size. That is 8 by 5. And this you can save even the graphs for plt.savefig, and you can write up the things to saving and that there. Okay. Okay. So you can just write it up like plt dot savefig, and you can write up your file name and like whatever you want. Okay, fine. So these are the things you can do in the matplotlib side. Just a glance of the things you can plot on. Okay, so a much of things you can use in the matplotlib. You can even plot up the variations, right? So like let's say someone is asking for the subplots, so we'll go with that. Okay, so let's say this is that, right? The f of t. Okay, and let's say to be return some values, that will be exponential, and minus t multiplied by the cost value of, let's say to be 2 cross np dot. So this is t1, which will be an range of 0.0 to 5.0, and in the intervals of 0.1. Okay. So this will be like my t1, the first point. Similarly, I'll take my t2. Okay, I'll take my t2 similarly, and that will be, let's take it to be np dot the arrange, and let it be 0.0, 5.0, intervals of 0.02. So I'll be using one subplot over there, and that is 2 to 1, right? That is 2 plottings, and it is the first one. So plt dot subplot, and for this to be plot, so t1 versus the f1, and that to be in blue dots, and similarly for the t2 with the versus the f of t2. Okay, right? So let's just subplot this. This was subplot of second one, that is 2 to 2, right? Similarly this side plt dot the subplot. Okay, let it to be t2, and this np dot cos of this 2 multiplied by this np of let's say pi multiplied by 2 times, or let's say to be pi multiplied by the t2 would be better. And so let's show this, let's see what comes. Yeah, there's one error. The last graph is not coming. Okay, so t2 multiplied by the np pi, and this. Subplot of NP dot N was literal values errors. Okay. Value errors are there. Minus T multiplied by NP dot cos of I multiplied by T 0.05.001 0.0500.02 subplot of 2 to 1 T1 of F of T1 with the 2. So these are the points coming up, and the last plotting is not being plotted and it's coming with some of the value errors. Alright, so we'll just write up with these. We are missing a very small thing. This is plot, and okay, this is subplot. Cool. So smaller, fine. So like this, as you can see the subplots at one time, right? So you'll be getting more than one plotting. You can even write it with the next plotting. So if you want with this, if you want it with the sine graphs too. Okay, fine. Someone is asking about the pie plottings. Okay, you want to see the pie plots? Fine. So pie plots will work as like pie refers to a circular graph, you can say, which is like broken down in various segments to, or I can say like it broken down in various slices, which is called as the pie slice, right? So it is used just to show the percentage of the proportional data you want to represent it anywhere else, right? So let's just take a simple pie plotting. Okay, so just take the days to be 1, 2, 3, 4. Okay. Let's take some activities time. So sleeping equals 7, 8, 6, 11, 7. So eating equals to let's take the working. So this is the working. It's the playing. Okay, and I will just plot these things like the sleeping, eating, working, and the playing. So let's say these are the activities of this person. Such activities. Okay, fine. So the activities are sleeping, the activities are eating, these are working, and playing. Okay, so these are 4 of the headings. Now let's write some colors to this graph. So let's see. It's magenta, it's white, red, and blue. Now these are the things you have given up, right? Now you want to plot a pie graph, that is plt.py, right? So what you will plot, right? First you have to plot your slices, right? That would be slices. Okay. Now slices, if we write, so slices has to be defined on. So let's just write point over there. let's write slices over there. 7, 12, or let's say 2, 14. So we want to plot the slices. Okay. So slices, leave the labels as activities. Colors as calls. And then we'll use this explode, and this explode is used. I'll just plot this and I'll let you know how this works. So this is there, we have 4 things, so 0, 0, 0 and 0.1. Okay, then we'll write autoplicity to automate the formulas. So this is actually a string containing of the percentage you want to print in the format. Okay. So this is fine. I think it's done. Let's plot this. So you get something so there, right? That has been with some of this. Now we'll try to understand what we have used. Okay, this explode is used, like you can see this last one, right? If you see the last, that is 54.2. That is your if you see up with it, this is a playing section, right? So we have given the last as 0.1, right? Okay, so that is like the playing area, and that has been exploded out, right? That has been taken out with a 0.1, right? So it has been taken out of it. That is the explode working. The autoplicity is like the values you will be writing on for your percentage. Like you have written 1f, you are getting one float value after this. Okay. Well, you can see some doubts over there. Vishal is saying they didn't understand the syntax and semantics. The semantics of subplots. Spend a bit of much time in explaining something like. Vishal, there are some students which are very new to the Python, so we'll have to explain those things. Okay. Okay. So we could not even just we will not just go and just skip those parts. Okay. So that is important actually for the new ones. That is included in your course. We'll have to go with this. So semantics you have not understood with the subplotting slide. Subplots is actually okay. We'll have to describe it more clearly. Fine. Okay, let's just go with the subplots again. See, so I can see you guys mostly having the subplots problem. So in subplots, you have some number of rows and columns you want to print, right? Okay, so if we just go with the plottings, let me give you a very clear idea with the subplottings. Okay, so let's say, okay, let's just say that you want to plot some 2 figures. Okay, you want to plot some 2 of the figures, and you are writing this as plt dot the subplots, right? And then you want to make it that you want some 2 rows and 2 columns, right? You have said that you want some 2 of the rows and 2 of the columns. Try to understand. Okay. So like once you have defined your figure and the axis, the A is the axis you are taking, that is 2 rows and the 2 columns, right? Then you can just write on this A of 0 of 0. That is the first row and the first element, right? So let this to be plotted up with the x. So we'll define the x1. Let's say this x to be an arrange. Okay. So this is an arrange of numbers, let's say to be 1 from the 5. Okay, so this is an range of numbers 1 to 5, and this is the first element, the first row and the first element over there. That is x comma x to the power of x. X multiplied by x. Okay. Now, if you want to set the titles too, you can even set this x of 0 and of 0, right? So that is underscore of set of title, right? So you can write title as the square. Similarly, you can plot up for a of 0 and then the second element, right? It's easy. I want to plot this up. Okay, and that is the, now let's take up the square root of this x. Okay, so the graph between the x and the square root of x. Fine. And we'll again just copy this thing and we'll plot this up. So this time we'll write this as to be the square root. Now again, now let's say the first row is over. Now we'll take up the second row, that is 1 of 0, right? And now we'll plot the graph between the x and the exponent value of x. Okay, and then we can just write the 1 of 0 to be the exponent value, right? Similarly, the a of 1 and the 0, 1, sorry, a of 1 and 1. So plot, and this time we'll be using, okay, so this is x and let's say this will be x, or let's say it will be log of x. So this is log of x. Okay, now you just show this up, right? Just show this up there. So you'll see a plotting with some, okay, so we haven't, there are some errors in setting of the title. Okay, so these are for 0, 0. So this is for 1 and 1. This is for 1 and 0, cool. This is for 0 and 0. This is for 0 and 1. Run this again, and okay, fine. Now you can see all the things over there, right? So this is like what we do, like the plottings. If you see, like the 2 rows and 2 columns you need actually. Okay, so that is subplottings. I think you might have understood, right? If you define other things there. So this is like basic use of subplottings, you can say, right? So the things you define on, like in the first case, if you see on the first one, the subplottings, the first thing we're defining the 2 to 1. Okay. So 2 to 1 is nothing but you want some plottings over there, that is x's, okay, and that is the first one you want, right? That is the code what we are writing here is the 2 to 1 as the first, or let's say this is the first graph you want to plot on. Okay, so you're having 2 graphs in which you're plotting the first one. Okay? This code is for the first one. Okay, and in the second one, this is the second graph, so we are using for the 2, 2 and 2. I hope you would be clear with this. If not, then you can again write it and I can again explain for you guys. Okay, so that is like exactly how subplottings works. Okay, so even you can just try it out with some different modules, right? So if you can just write with the subplots of 2 cross 2, right? So these are nothing but the axes you want to plot on. Okay, so you want to plot some 2 graphs. Okay, 2 graphs, and this is the first graph, and this is the second graph. Okay, I think you might be clear with this. Okay, so these are all the things we do up with this matplotlib and all those things. Okay, something Vishal has written, you can probably tell us what each line is doing there. See, if I just read over the things, like for writing up only the things, right? So for the newcomers, it's not very easy to understand each thing in one line. So that is like necessary to go on with all these things. Okay, so I hope you understand, right? So these are the things, guys. We start working with this things up, right? We completed this NumPy and this matplotlib. Tomorrow we'll go up with the pandas and this Seaborn. Okay. All right. So if you write subplot of 2 to 3, right? If you just write subplot of 2 to 3, that would be like, if you want, then you would have to mention that with the third graph. So that would be 2, 3, 3. Okay. Then you should mention it to be 2, 3, 3. Like in that case. Right? Okay. What is the width in the histogram? The width is like, the width we are using, R width is nothing but the width of the bar we are having in this histogram. Okay. All right. The row which we are having using this. Logs in 2. Log is in 2 to 4. Yup, in here in this case. Okay. All right. Fine. So we'll meet up tomorrow, guys. Okay, with the 8:30 p.m. right, and you will be having your examination tomorrow at 11 p.m. Tomorrow we'll be going up with the pandas and with the pandas and with the seaborn, right? And we'll see some more things regarding to this data, presenting the data structures, the or you can not the algorithms, the data plottings, even which with very more better ways. Okay, so like that we can use it. Right? Okay, cool. So you'll get your files in your drive link, right? You have this drive link in, I think this is on your Telegram, so you can find it out there, right? Okay, guys, fine. We'll meet up tomorrow.